All right, cool. So let's go ahead and get started. This is strategies for engaging lower level physics learners. Just a quick heads up that it probably warned you that this is going to be recorded. I had a number of people ask me to send the recording out afterwards. And so just a heads up that this is being recorded. So yeah, first I just want to start with a little bit of background. Yeah, and so please during this put any questions that you have in the chat. We have a pretty big group, but Abby is here to do the chat, and she'll interrupt me at any time. And I love to take questions even in the middle of a presentation. So please keep that in mind. I'm going to ask for a survey at the end. So I know some of you wanted a certificate of attendance that you can turn in for PD hours. We'll go ahead and um, do that towards the end. And then also I'd love to get your feedback on this presentation. So a little bit of background about me. I taught for 13 years in what was originally Memphis City Schools, now Shelby County Schools. This was my first year at Kingsbury High School. And these are my students, but they didn't always look so happy. So my first, especially a couple of years, I really struggled. So if you imagine, if you ever think you've had a bad day in your physics class with students not feeling like students didn't learn much or get much out of what you were doing, I definitely had that as well. Mine was probably a lot worse. So I was trying to teach physics like this to a lot of students who were way behind in math. A lot of them the previous year, they didn't even have a math teacher. And so trying to teach students like this, they got really frustrated with me, and also actually led to tons of classroom management issues. But fortunately, over the years, I committed to teach for 2 years, but ended up sticking around for 13. I figured out some strategies that work and would love to share those with you. But the biggest one, I think, and in the title of this, I put engaging students. But I feel like sometimes we think engaging means that we have to have, especially as science teachers, we have to have things blowing up in the front of the classroom or things like that. But I think the most engaging thing for students is when they feel like they're capable of being successful and capable of doing challenging things. So my strategies really revolve around how do we make sure that all of our students can feel like they have a shot to be successful. And even if they struggle in math, I don't want, even if they're down the hall struggling in their math teacher's class, I want them to feel like they have a chance to really be successful in physics class. So I came up with 7 strategies that were my top 7. The first 2 are kind of the most important to me, called the building block method and then giving students pre-manipulated equations. And at the end, you'll probably see that I make a number of references and use some screenshots from my website, Positive Physics. I know some of you use that and some of you don't. If you want a quick tour of that at the end, I'm happy to stick around and do that. But in general, I hope these strategies, they can be used by people whether or not they use positive physics. So first, again, taking a look back at, this is kind of the way that I was taught physics, and it's the way it's traditionally taught. And if you kind of look at this from the perspective of from a lower level student, especially one who might not be confident in their own math abilities, this can look super intimidating. And I think the first thing is, I noticed when I was teaching these like a problem like this, it would take me maybe 15 or 20 minutes to go over a question like this with my students. And by the time I asked them to practice on my own, they'd completely forgotten how to even do the first step. And so even if I went over 2 or 3 problems like this, like, they still just weren't getting enough practice just doing the first step and knowing how to get started. So to me, when I see this problem, I see it as 4 separate skills. So this is like a box sliding down an incline. So the first one is just, and so I do this for all of the skills, but I want to give an example of how I attack like the forces unit, and especially like forces unit that involves trigonometry. So I really see this as 4 separate skills. So first, drawing free body diagrams or identifying the forces that are acting on an object, then doing trigonometry, then analyzing a free body diagram, and finally, like, the 4th skill is putting it all together, like with Newton's second law and things like that. So when I teach a lesson, instead of starting by presenting students with something super intimidating like this, I would just have students practice drawing free body diagrams. So this is a full day's lesson for me. Is just giving students tons and tons of situations where all they're doing is just identifying the forces acting on an object. And as we all know that like when a student gets really good at drawing free body diagrams, then they start doing much better. Like this is a skill that will really help them throughout like in many different units in physics. So then even with my lowest level students, I have them do trigonometry. But I isolate it as a completely separate skill. So this is a separate day for me. And all students are doing in this is they're just practicing the trigonometry part of this question. So trigonometry especially can be super intimidating for students who are like, especially if they're low in math. And it's hard enough like on its own, but when you really combine it like within the rest of a problem, it seems almost impossible to them. But if you can isolate it and have them just practice like just that one part of it, it becomes a lot more doable. And then this third skill was a real game changer to me, like analyzing free body diagrams. When I realized like, hey, I can start giving students problems where I've already done part of it, and we're just once again just like isolating this single skill. In this case, it's finding the net force and determining if an object's speed is increasing, decreasing, or constant. And I like to give students practice for them, like doing it what I would call forward, which is on the left-hand side, where students are like balancing a force if it needs to be balanced and finding the net force, as well as doing it like backwards, where you're giving students the net force and then asking them to find a missing force based on the net force and a description of the speed. And so by isolating this skill, again, they can just get really confident with this one kind of single part of the problem. And also you can ask them to kind of do this question in all different orders. And it was the same thing with the trigonometry, where they got practice doing like, oh, if they were given the hypotenuse and an angle, or given like two other different givens. And then finally, like once students have mastered all of these skills, then it's time to put it all back together to solve kind of a similar problem to that problem that I showed you at the start. And so I really found that teaching like those isolated skills or building blocks really helps students figure out how to put all of this together. On top of that, so not only do I recommend like teaching those building blocks separately, but I think it's really important to assess those building blocks separately as well. I had a number of students, my lower level students, who probably weren't ever going to get to the point where they could put it all together. But the nice thing about putting these separately on the assessment is students can prove to you the things that they do know. Like sometimes if my original assessments where I kind of just gave these complete problems, I get some students turning in like assessments that were blank or nearly blank because they just had no idea how to get started. But if you assess each one separately, like even if a student doesn't have it all figured out, they really like the ability to show you, like to be able to show you like what they do know. And it's also just really useful as a teacher. It can help you figure out what part they're getting stuck on, whether it's the trigonometry or the analyzing the forces or drawing the forces. But just making sure that you give students every opportunity to show to you what they actually do know. All right, so that was my first big tip, and that one was a real game changer for me. The second one is a little bit simpler, but I figured out that a lot of my students, like especially the ones that were lower level in math, and I think somebody even put this in the comments when they wrote when they signed up for joining this meeting. They said, I have students who can't solve like the simplest 3-variable equation. And I know like math teachers might not love this, but I see physics as a worthy subject itself, and not just a way for students to practice math. So for my lower level students, I give them an equation sheet that has the equations pre-manipulated on it. So they just feel free to focus on the physics themselves. And so that's actually like what it really surprised me how much my students, even my lowest level students, trigonometry became one of their favorite things that I taught them, because with these manipulations added, they were really able to see like they're really able to do trigonometry and be successful at that. And this just little addition of giving them the pre-manipulated equations was a huge benefit. Abby, if you don't mind putting in the chat the link to the positive physics equations and definition sheet. Basically, if you want to use this, it's no need to use the rest of the website if you don't want, but this is an equations and definition sheet that has all the equations on there pre-manipulated like this. And so so if you want to use that with your students, you are welcome to. Also, I'll send you guys a follow-up email with the recording, and I will include a link to this in there as well. All right. And yeah, thanks for putting that in the chat, Abby. Cool. Actually, let me pause real quick. And if you do have any questions, feel free to put those in the chat, and then Abby will interrupt me.
We had one question, which was with the free body diagrams, do you do them separately from the trig, or do you have them do both steps in one?
Gotcha. I'd have them do it separately from the trig, especially when you have these ones are really complicated like themselves, like getting students used to, in this case, like anyone who's taught physics before knows that when you give a student an object that's on an incline, 90% of them want to rotate the weight. So kind of teaching them like kind of which forces are going to change with the with the slope, and which ones are going, and that the weight is going to stay kind of vertically straight up and down. I think that's a big enough skill alone. And then I would wait until they're really good at doing this before introducing the trigonometry at all. Oh, and Abby, I grabbed this one. So Rebecca said, I have a lot of students who don't understand how to substitute variables into equations. Is there a strategy to help them? That's a good question. Gosh, I guess just kind of teaching that as a completely separate skill, like sometimes I do a day like earlier in the school year where like that is the only thing that we're focusing on. So I think just giving like any time like they're having trouble with anything like that, just trying to really isolate that skill and then just letting them practice just that skill would be the way that I would do it. Gotcha. Abby, did you want to add anything to that?
One other thing which I found helpful is having, when you have the equations, make sure there's also a list of what the variables symbols mean and what they represent, because I think sometimes students see the equation and they're like, oh, I don't know what any of those symbols mean. So then they can't put the numbers in. But I found giving a list of the variables and the definitions helps as well.
All right. Then, as you might have also noticed, as I went through like the way that I would change this problem on the left, break down this problem on the left, is also just using like simpler notation. So this example on the left is especially bad, but just some of the notation just used in that problem, especially like we talk a lot about our students that are on lower math levels, but we probably also have a lot of students that are on lower reading levels. And so just making sure, I recommend using notation that's as simple as possible. It can be a huge help for students. In addition, if you notice on the left-hand side, this example problem is like a box on an incline. And as I know some of my students would get confused by like, what is the math and what is the actual diagram? And so I just highly recommend, and in physics, we're super lucky that we can almost always come up with a situation that a student is familiar with. So I really prefer like a bike riding up a hill as opposed to like an abstract box on an abstract triangle. Yeah, I should note, I see a couple comments in the chat that I was super lucky teaching in Tennessee that I didn't have a state test to teach to. So I was really just teaching to making sure they're successful. But even if you do have a state test to teach to, I do think like it's valuable to do this. And I highly recommend having students really thinking about what we ask students to memorize, and yeah, making sure like there's a reason for it. If they don't have to memorize something, then I try to keep the amount that we ask them to memorize small. All right. A couple other quick assessment tips is I really like to make my tests similar to the homework and classwork so students don't feel like they're surprised. In fact, I actually would give students exactly the same questions on their assessment as the homework, just with the numbers changed. Again, I mentioned before, like a big one for me is testing those isolated skills. Not only is it great for understanding what your students know, but I think students really appreciate when they can, even if they can't put the whole thing together, they can really show you the things that they do know and that they're getting points and getting rewarded for that. One other thing that I like to do is for students who really struggled, actually for all my students, I offered them this opportunity, is they could use notes on their assessment if they wanted to. However, if they used the notes, I capped their grade at 80%. And the great thing about this was students didn't feel like they were singled out by like, hey, like that student can use notes, but I can't. But my higher level students, they're like, no, I'm not going to do that because I don't want my grade capped at 80%. But for some of my lower students, they're like, okay, like I'm willing to take that for now. And it was pretty cool to see even some of my students, they would use them at the start of the year, and as they gain confidence, they'd even come up and tell me like, I don't need to use my notes this week. So I thought the grade cap was a kind of nice way to do it, so it didn't feel like different students were getting different things. All right. Then another one, I know some people use the guess method, and this is similar to that, but slightly different. And so to organize a problem, I really like students to always write out like all of the things that they're going to solve for. So whenever my students see like a motion problem, they know they're going to write out these 6 things. You might do 5 things. I really like for students to calculate the average velocity. But oops, let me get back to that. So then a really nice thing here is that my students also know, it's drilled into their heads that for a one-dimensional motion problem, they need 3 given. And so they list out all the things that they need, and then they're filling out the 3 given, and then they can use those equations to figure out what comes next. Kimber asked, do you collect or keep notes when they use them for confidentiality of tests? Do you have issues with integrity or cheating with the use of notes? Yeah, so I use my my system Positive Physics for all of my assessments, where everything is super randomized. So I actually didn't really need. I can show you more like what I mean later with a quick tour of Positive Physics, but my assessments were randomized enough that I didn't like have any issue with that. And it looks like some people are offering some good hints in that they collect it at the test and then return those later. Yeah, but again, this starting with a list, I found it really helpful. It not only works for motion, you can make some modifications for it for other things. So for momentum problems, I always have my students write PMV underneath each object that's moving. And it's a really good way for them to identify kind of what to do and what comes next. It's a little bit trickier for an energy problem. I start by having my students identify the type of energy present at each time, and then underneath the type of energy, underneath that, just listing kind of what goes into it. And again, this really helps students kind of visualize like what they need to calculate next. One other thing, this is like I had students who got really hung up on the negatives. I've a little bit mixed feelings about this strategy, just because it doesn't set up students super well if they're going to take physics in college. But for some of my lower level classes, I developed something called the Scalar method, which essentially is instead of velocity and displacement, we use speed and distance. And then you actually don't have to worry about any negatives. You always calculate distance with distance equals average speed times time. And it can be a really good way to not have students get hung up on the vocabulary, like, or negative signs. I can talk a little more about this later if anybody has specific questions about this, but this is also really helpful for my students. And then I'm actually going to ask a question on this one. So I want you to tell me how much current flows through resistor A in this problem. Please put your answer in the chat and tell me how you got it. All right, cool. I see a lot of people saying too. Oh, and sorry if it was really small. All right, so I see a number of different answers. The answer that I got is 2 amps. And so I know a lot of people didn't answer this yet. But the key point here is that you don't have to calculate the full equivalent resistance of the circuit first. So, well, let me use the annotate tools on Zoom. And sorry, I think I just accidentally unshared my screen. Abby, did I unshare my screen?
No, you're good. It all looks good.
Okay. All right, so I have my students analyze. This doesn't work for every circuit, but it works for 90% of them in all like practical circuits. And Abby, can you see my annotation? I think I might have messed
I
something.
don't see anything yet.
All right, hold on. Let me try stopping the share and resharing. All right, can you see it now?
Yeah, that's working.
So if you follow, forgive my sloppy tracing. If you have students analyze circuits route by route, then, and this only works if there are distinct routes on it, then we can say, okay, the voltage for this route supplied by the battery is 20 volts divided by the total resistance on the circuit is 10 ohms, giving me a current of 2 amps. And then, so if you have students analyze circuit or route by route, instead of focusing on like figuring out the equivalent resistance first and then trying to like do it the super mathematical way, it's a really conceptual way to do it. And they can solve 95% of circuits, of practical circuits, they can solve this way. But just a quick tip on circuits. And again, I'm happy to take more questions on that. But I got away from really focusing on equivalent resistance, and circuits went from maybe my students in my least favorite part of the year to maybe my favorite part of the year. All right. All right. And yeah, I'd love to pause and see if anybody has any questions. Also, Abby, will you please put the link to the survey in the chat? Real quick, if you fill out the survey, I'll send you a certificate of attendance. One little thing is I'm using like a mail merge tool. It'll also add you to our mailing list. But so if once you get your certificate, if you want to unsubscribe, completely understand. Otherwise, you'll get a email every few weeks about positive physics. But again, please fill out that survey. Also, if you have any feedback on this, please let me know. And then if you do have questions, I would love to hear those.
There's a question about the scalar method, which is, does that only work if the motion is all in one direction?
Yeah, good question. So really good question. So if I have an object that's going up and down, to use the scalar method, I would have students scratch out the second half of the problem and only analyze it while it's moving up. So if something was launched at an angle, for the y direction, I'd only have them analyze the first half and then understand that the time that they calculated was the rise time. And in the x direction, they would just double that time when they plug it in for their x value. So it adds a little complication that you got to be really careful about your times, but it still really simplifies the math, especially if you're always calculating the average speed. You don't need any of these, like any of the more complex motion equations. You just have to have students be really careful about the times, because if you have something launched horizontally, kind of your y time and your x time are the same. But if you have something launched at an angle and coming back down, students have to keep in mind that, oh, for the y, I'm going to analyze just the first half, and for the x, I'm going to have to double that time to figure
Assuming
out.
It's starting and ending at the same height.
Assuming it's right, and then
and you're not launching things off of cliffs or.
But my students actually would do that, but then on that it was longer, but I actually loved how conceptual it was. They would analyze the object on the way up, and then they would do a separate y. So they do kind of three calculations. Okay. They do y up, y down, and then x. Good. Thank you for catching that. All right, Tom said, I have some 10th graders that couldn't understand basic algebra functions. Some were confused by -0 = 4. Tom, I think I might be a little confused by your question as well. Tom, do you mind just unmuting and explaining what you were asking? Oh, gotcha. Oh, I missed it. My bad. It was just split on 2 lines, and there was something on my Zoom that was covering that up. 4 minus 0 = 4. Yeah. So I think kind of like isolating skills again is something that I would really consider doing. So thinking about like take some time away from like the physics teaching to just focus on some of the math things. But I would recommend, like, I don't think starting with math is a very exciting way to start the year. So if you can start with some of the physics, and then like kind of periodically throughout the year, just like completely taking a day off from the physics just to work on those math skills, is something that I would recommend doing. Because I think when they run into those kind of in the middle of a problem, like we really want to make sure that they have the confidence built up from before. Yeah, so Zach definitely agree that the negative just indicates a direction, but I still found that, like, and again, that like I'm good with teaching it, like I taught it both ways. Differentiating between like what a negative displacement, a negative velocity, and a negative acceleration all kind of mean different things. And I think that in some cases it can be valuable to like use the scalar method. So students are thinking more about the physics than kind of trying to memorize the rules about what a negative, like how a negative displacement is actually different from a negative velocity. Cool. Any other questions? And then also, if you want to stick around, I'm happy to show you Positive Physics. So Positive Physics is a website that I made for my students. It's actually become my full-time job. There's lots of freebies on the site, but it is a paid resource, and I really wanted this to be valuable for people whether or not they use Positive Physics. However, we always hope that like the school can pay, and if you want to use Positive Physics and money is an issue, we just if a teacher's paying out of their own pocket, they get to decide their own price, because I really want people to use it. Yeah, so I'll show you that in a little bit. Trisha had a question. Will you be sharing a link to the slides, or should I just wait for the recording to go out later? Yeah, I can. I'll just send the record. If you want anything more than just the recording, please reach out to me. You'll get an email from me, so you can always get my email. So I always reply from that if you need anything more than the recording. Jack V said, does anyone else prefer to discuss vectors/vector addition using trig before even discussing velocity and acceleration and forces? Somebody thumbs up that. Yeah, would typically cover velocity and acceleration before introducing vectors. Yeah, personally, I really try to just only teach the math like kind of as needed as we go through. I'm a little like, I get students, especially my lower level students all the time, that are like, I hate it when they say like, this is just another math class. So I try to really like avoid starting the year with just pure like math and kind of teach it as needed throughout the year. Sandra said, learning challenges have been accelerated due to COVID isolation. Is there an easier physics program than what you are showing us? So yeah, I know I took you through like kind of like an inclined forces problem, which is pretty challenging. Let me show you kind of like what I do on positive physics and kind of how it scaffolds up, if you don't mind. But again, if you got to take off, thank you so much for coming today. I really, really appreciate it. All right, and then Abby, if you don't mind, like interrupting me if you see a question. I can't see the chat anymore.
Okay.
Yeah, so real quick, this is a website that I built for my students. It's called Positive Physics. It was originally just a classroom website, just for my students, and it's now being used in a lot of other classrooms, which still blows my mind. So yeah, it really incorporates a lot of the things that we talked about, but a huge benefit is it gives instant feedback. The first 5 units are completely free, so feel free to give it a shot with your students. But it starts kind of by breaking down, this is our forces unit again, and it breaks down questions into bite-sized pieces. So like in this lesson, which all the lessons start with a quick video, it gives students the opportunity to just identify, like looking at different situations and looking at the green object, just identifying like what direction do the weight, normal force, and tension act. And then introducing all the forces in the next skill. And then in the skill after that, it's like, okay, we've already know, like students have already practiced drawing the forces. So let's just give them that and let's just focus on how students find the net force. When we have numerical problems, anything in blue is randomized. So it's really cool. My students sit next to each other and they just, once they realize, and so some of them gets frustrated. It's hilarious that when they realize that every student has different numbers in their problems, and then they start realizing they can't just tell each other the answers. They have to tell each other, tell each other the strategy. So as they practice, right answers turn green and wrong answers turn red. By the way, I'm hitting enter, or they can click check answers. And when those are corrected, we keep track of 2 different scores. So completion score means they got it eventually. Accuracy score means they got it on the first try. I highly recommend always grading homework for completion. And this really scaffolds down to through the different skills, vocabulary, and concepts, questions where students can check their answer every single step of the way, to later taking away that support and just having students do kind of traditional complete problems. And once again, they still do check their answers one at a time as they go through. Oh, and again, if you have any questions, definitely put those in the chat, and Abby, you can interrupt me. And then all the way down to like challenge questions and multiple choice challenge. And these are more like honors or AP level questions. So I guess a question somebody asked before was, do you have anything easier? And I think like the easier, like the I really think that any of my students, even those who had like pretty low ACT scores, could get through at least like the preparation problem. So I really tried to make something that like was really scaffolded upwards, so that I really think like any student, IEP students, English language learners can get through at least the part that says preparation problems. Similarly to kind of what I was recommending before, we have an assessment that literally takes the exact problems that students saw on their homework, and it puts them into an exam. It's randomized enough so that of these 11 questions they saw in the homework, every student gets 3 different questions, 3 questions randomly pulled from those 11, and it tests these individual skills as well as like the complete problems. So students, even if they can't get those complete problems, they still have the opportunity to show me what they are capable of doing. And of course, like I can see all of their results in real time, and even see like I look at their accuracy, kind of see what they missed. So the student missed the net force, but they corrected it later, is what the different color green indicates.
We have a question,
Sure.
which is there an option to print anything for working kind of with a whole group?
Yeah, so two things. So first, there is this print feature. It will generate a PDF. I usually recommend just like printing some of the skills. So let me take off a few. And sometimes it freezes when I'm on Zoom and show this print feature, but essentially it will print out all of these questions. Oh, and by the way, this part is free. If you don't want to pay for the site and you just want a screenshot from the site, you have my permission. I want this to help as many people as possible. And if you know Bill Gates and can make this free for everyone and still allow us to keep it afloat, please let me know that as well. Oh, I printed out a lot of the skills. But anyways, it will generate a PDF for you that you could use as a whole class. I used it like have my students show their work. And so anywhere there's a random number, right now it fills it in with a blank. We're working on some things where you can actually print out a PDF that will include the numbers as well. So yeah, this goes through and it prints out all of the problems. So you could use that with your class if you wanted to. But again, when it gets to like questions with numbers, right now it's putting a blank, because if you're actually using the system, every student would get different numbers in their answers. Oh, I saw people were answering my question already. Thanks, Matt. Cool. Okay. Yeah, I just wanted to give a really quick tour on that. I'll probably do another webinar or something later where I really go through all the details about positive physics. But again, I wanted this one to be really useful for people, whether or not they used positive physics. So let me stop right there. I'm happy to hang out and answer any more questions if people have them. At this point, I think you can just unmute yourself and ask a question. But again, feel free to take off. And yeah, thank you so much for taking time out of your summer to join this. I can tell your students are lucky to have you if you are willing to take an hour out of your summer to come to this presentation. Matt asked about pricing. The pricing is right here. If you go to grab a quote, just remember that these are the prices if your school or district is paying. So if for one teacher and unlimited students right now, it's $399. But if you are paying out of your own pocket, email me. I'll send you a link with a pay what you can quote, and then you can literally pay whatever you want. Abby, will you put the link to the certificate in?
Yeah, I'll do that again right
now.
Yeah,
real quick. I should have explained for the certificate. I'm gonna get a whole list of those as a Google Doc, and then I'm gonna email you your certificate and use mail merge, so I don't have to do them all individually. But thank you so much for coming out. If you haven't already, please fill out the certificate of attendance survey if you would like one, and I'll shoot you that probably sometime tonight.
You said we can unmute for questions, right?
Yeah, please.
My school is fully embracing standards-based grading now. And so you mentioned possibly for the homework grading not based on the accuracy, but upon completion. For an assessment, how might you go about grading something like that? Do you now look at the accuracy? Do you somehow, like, I don't know, average them somehow? What is your process like?
Yeah, for the assessment. So let me show you that real quick. Sorry, I have so many things on my screen right now. Let me get to a question I can answer easily. So for the assessment on this website, it's slightly like on our assessment mode is slightly different. So if I'm a student and I get something wrong, so let me say the net force is 0, they can't fix it immediately. So I'll get something right as well. This was a decreasing speed. You'll see, okay, my score goes up every time I get an answer right. And then when a student is done with the assessment, they click finalize. And then once they've tried every question, they click finalize, then they can start making corrections. And when they start answering those, they get a separate correction score that starts to increase. And so what I would do, I put in the original score just as a grade itself, and then I put in a correction score as a grade. I think I had it worth about equal points. And so essentially it was averaging together their completion and their accuracy. One really nice thing here is if you go to student scores, I guess I don't even need to show you that. I can just tell you that you can restart. So if you want your students to have unlimited chances, you can just with one button click restart, and it'll give them a completely new, completely re-randomized assessment. If you're doing standard-based grading, when you look at their assessment, you can see their score on each of the skills. So if you could use this as like your standards, it could be, or combine some of them together, it could be really useful because you can see kind of what your students are doing well on and what they still need to work on. One other option would be to use, we have this other mode I didn't show called extra practice. And essentially that just generates a mini quiz. Like this one, it's going to randomly pull 3 of those 17 questions, and it's just going to give them a like 3 randomized questions that are from that specific skill. So that might even be worth exploring. On this one, after students finish, they can actually restart it and do it as many times as they want. So that could be another option. Tom, I started rambling. Did I answer your question?
Yes, thank you. That is very helpful.
Sure. I'm reading from Jack V uses this a lot. So he says, I routinely average my first attempts and corrections on assessment. In doing this, I almost never need to curve anything. Gotcha. Okay, very cool. It's cool for me to see people use the site in all different ways that I never thought of, and it's very cool. And thanks for adding that, Jack. Okay, great. If that is it, again, thank you so much. If you do check out Positive Physics, so you guys have my email anyways, or it's right here. I'm always happy to help if you need anything. And yeah, thank you again for coming. And please do reach out if you have questions. My favorite thing that I'm super lucky that I get to do this as my job, and my favorite thing is helping people out. So yeah, thanks again for coming. And yeah, I look forward to hearing from you.